There's an old physics joke which goes like, in the beginning, God said, let the total derivative of an antisymmetric rank 2 tensor be 0, and there was light. But in all seriousness, it's crazy that we can get such higher dimensional objects, and then when we bring them down into our 3 plus 1 dimensional space, we get something like Maxwell's equations, which completely dictate how the electromagnetic force works. The first of these equations is called Gauss's law for electricity, and basically it tells us that electrons are the source of the electric field lines. No matter what shape we draw in space, the electric field lines coming out of it is proportional to the amount of electrons inside of that region. Similarly, we have Gauss's law for magnetism, which tells us that magnets actually have no source. In other words, every magnet has a north and a south pole which perfectly cancel each other out. We also have two equations which tell us how electric and magnetic fields interact with each other, such as the third equation, Faraday's law, or induction, which tells us that if you move a magnet around, it induces an electric field in wire. Lastly, we have the Ampere-Maxwell law, which tells us how changing electric fields creates magnetic fields. In fact, it gives us a very particular time of evolution of both, and this is what allows for light to propagate. Now, Maxwell discovered these equations back in the 1800s, about 100 years before Einstein came up with special relativity. So this guy was a real genius. In fact, some people think that he may have discovered special relativity in some way in his time and took the secret to his grave. In some way he did, though, because these equations that he discovered were posted near his gravesite, and they actually happened to follow special relativity and were a massive insight into how special and even general relativity work to Einstein down the road.